We're now going to talk about how to graph exponential functions. Now, so we just have a to the x. Either it looks like this, or it looks like this. A to the x. Y equal a to the x. It's one of those two graphs. You don't need to remember this, but is this graph if a is bigger than 1? If a is bigger than 1. And is this graph if a is less than 1 but positive? You don't need to remember that. If you were asked to graph y equal 2 to the x, you do it with 2 points. You let the exponent be 0, and you let the exponent be 1. You find the y values. 2 to the 0, you have to know what that is, it's 1. And 2 to the 1 is 1. With these 2 points, and only these 2 points, we can graph this. When x is 0, I go up 1. Of course, there's an error here. 2 to the 1 is 2, excuse me. When x is 1, I go up 2. Now, either I am going to draw something that looks like this, or I'm going to draw something that looks like that. And if I'm going to hit those 2 points, it's going to be that. That is, there's your graph, 2 points. If you have a teacher who says you have to plot more points, fine. Do exactly what I did, and now make your teacher happy by picking other points. But nonetheless, we were done already. You only need to plot these with 2 points. Let the exponent be 0. Let the exponent be 1. If you are asked to graph y is equal to 2/3 to the x, plot 2 points. Let the exponent x be 0 or 1. You need to remember that anything to the 0 power is 1, and anything to the first power is the anything. And that the graph looks like one of the 2 on top. When x is 0, I go up 1. When x is 1, I only go up 2/3. When x is 0, I go up 1. When x is 1, I only go up 2/3. That's this type of graph. Like I said, a, the base, 2/3, is less than 1. So, we give you a graph, an exponential graph, and we're going to try to find the equation of it. Okay, so you're given this. And you have y is equal to a to the x. Well, this point right here is understood to be 0, 1. Well, if x is, regardless of what a is, if x is 0, you get 1. So that point is going to work. But we need to find out what a is. Now we know that when x is 2, y is 9. We know when x is 2, y is 9. Well, if a squared is 9 and a is positive, then a is 3. So we're done. Y is equal to 3 to the x. Now, why does the base a have to be positive? Well, for those of you who care, the reason is you can take, say, 3, a positive number, and raise it to the square root of 5. And that's going to be a positive number. But what if you had negative 3 and you raised it to the square root of 5th power? Well, we wouldn't know if that's positive or negative. Again, I may have said to the 5th power. I meant to say to the square root of 5 power. If you raise 3 to this irrational number, you know the answer is positive, and your calculator will give you an exact answer. But with this one, it's going to give you an error. You can't have square root of 5. You can't have irrational exponents. You can't compute negative 3 to the pi. But you can compute 3 to the pi. Take your calculator and do it. But you can't do negative 3 to the pi. So a is always positive. That is why when I had a squared is 9, I didn't say a can be plus or minus 3. Okay, so that's the answer to that problem. You were given the graph and you found the equation of it. Let's play the game again. I'll give you a graph and you find the equation of it. And of course on the graph I give you some points. We have this graph. It has this point, negative 1 and 1/5, and it crosses at 1. So this is all you're given. You need to be mathematically mature enough to realize that that point is x is 0 and y is 1. Okay, so y is equal to a to the x. Well, here, if x is 0, y is 1, regardless of what a is. Now, when x is 1, y should be a 5th. I meant to say if x is negative 1. So, if x is negative 1, y is a 5th. Well, this is 1 over a. This is 1 over a. So, if you start off with the same numbers, 1, and you divide one by 5 and the other by an unknown, and you get the same answer, well then you divide it by 5. That is, a is 5. So, updating the first and last piece of information, we know y is a to the x. But now the last line told us what a is. So there it is. Y is equal to 5 to the x. This point is 2, 1/16, and they tell you that the y value there is 1. Well, once again, this is telling you 0, 1, which means it's y equals a to the x. Because if x is 1, I meant to say 0, x is 0, a to the 0 is 1. Okay, now we know that when x is 2, y is 1 over 16. So then a will be plus or minus, but since a is known to be positive, a would be plus the square root of 1/16. The square root of 1 is 1, and the square root of 16 is 4. You can take the square root of the top and the bottom separately. The a is a quarter. So, updating these two pieces of information, we now know that y is equal to a to the x. Okay, so what if we play games with shifting? Now, remember, in these graphs, either it looks like this, or it looks like this. In either way, they're getting closer and closer to y equals 0. Y equals 0 is a horizontal asymptote. Okay? Y equals 0 is a horizontal asymptote. So, if you were asked to graph y is equal to 2 to the x minus 5 plus 1. What you want to do is find, so this is a shift. You want to find their vertex. The vertex has always been what makes that 0, 5, and what does that say? 1. That is, our graph is going to behave as if the origin is right here. It's going to behave as if these are the axes. Remember, we're supposed to get closer and closer to the horizontal axis, the y-axis. Okay, like always, and I was very careful in how I said things, like always, let the exponent be 0. That is, let x be 5. And let the exponent be 1. If x minus 5 first should be 0, adding 5 to both sides, x is 5. If you want the power to be 1, add 5 to both sides, and now you know x should be 6. Let the exponent be 0 and 1, and find the y value. Let the exponent be 0 and 1. In this case, that means let x equal 5 and 6. Well, if x is 5, 5 minus 5 is 0, 2 to the 0 is 1. If x is 6, 6 minus 5 is 1, 2 to the 1 is 2. Same answers as before, 1 and the base, 2. Okay, so when x is 5, I go up 1, which happens to be right there. Which greatly disturbs me. Oh, excuse me, plus 1, plus 1. 1 plus 1 is 2, 2 plus 1 is 3. We just found the values of that. But to get y, it says to add 1 more. So when x is 1, I'm at 2, I'm right here. And when x is 6, when x is 6, I'm at 3, right here. Again, either we draw something that goes like this, or we draw something that goes like that, and we get closer and closer to the y-axis, the new y-axis. That is, the graph goes like that. The graph goes like that. Let's try another one. Suppose you are asked to graph y is equal to 2 over 5 to the x plus 2 minus 3. Okay, what is the vertex? What makes that 0 is negative 2. What this says is negative 3. That's the new origin. That's where the origin really is in our mind. In our mind, that's where the origin is. X is negative 2, y is negative 3. It says that this is our y-axis as far as we're concerned, and this is our x-axis. Of course, we label the other ones x and y. But in our own little mind, that's actually wrong. You can think of it as being wrong. Okay, we want the exponent to be 0 and 1. Well, the exponent is x plus 2. When is it 0? When x is negative 2. When is the exponent equal to 1? That happens to be when x is negative 1. Okay, so I make my exponent 0 and 1. That doesn't mean I let x be 0 and 1. Why? Because the exponent is in x. When the exponent was x, we said x is 1. We said x is 0. But when the exponent is not x, it probably won't turn out that 0 makes the exponent 0 and 1 makes the exponent 1. Okay, now when x is negative 2, the exponent is 0. 2/5 to the 0 is 1. But let's not forget to take away 3. 1 minus 3 is negative 2. When x is negative 1, the power will be 1. So here we have 2/5 to the 1, or 2/5. And then when we take away 3, we get negative 2 and 3/5. When x is negative 2, I go to negative 2. I go right here, negative 2. When x is negative 1, I go a little bit lower. When x is negative 1, I go a little bit lower. And then I draw my graph. Get closer and closer to that dotted line. Don't cross it though. And there's your graph. 2 points. Okay. Now, to convince yourself, maybe I should have said this at the very, very beginning. Convince yourself that either exponential graphs look like this or look like that. How might you do that? You take different numbers, 3 to the x, 11 to the x, 2/3 to the x, 5 over 18 to the x, different number to the x's. And you will see that you only get, and you graph them, y equals that, plot many, many points. Plot as many points to you to be convinced that, in fact, the graph, you plot all those points and you say, oh yeah, it does go like that. Or in another case, you plot all these points and you say, oh yeah, it really does look like that. Plot enough. That way, we know that it's going to look like one of those two on the top, and then we only need a couple of points. To argue it very clearly, if you're either going to draw this or that, and I give you 2 points, well, with these 2 points, you're not going to be able to draw anything that looks like this. It's going to have to be that one. If you have just 2 points and you know what it might look like, if you have these 2 points, it has to look like this, because you're not going to be able to draw anything that looks like this, whether it's that one, or a little higher, or a little lower. They're never going to cross those 2 points. Okay, so that's why we're getting away with graphing it with 2 points. So convince yourself that they look like those two, or take my word, and then you'll get them all right. Now, so graph y equals 3 to the x, and then after that, graph y equals not 3 to the x, but negative 3 to the x. This is negative 3 to the x, is not negative 3 to the x. For example, if x is 2, it's negative 3 squared. It's negative 9. This here is 3 to the x. And for different x's, you get some numbers. Now I put a minus sign in front of it. If this is 11, then it's negative 11. Then the whole thing is negative 11. Okay, and remember from before, if you put minus in front of a function, it's a reflection across the x-axis. That is, if y equals f of x looks like this, this is y equals f of x, then y equals negative f of x will just be the mirror image. This is y equals not f of x, but negative f of x. And knowing that, we can easily graph these functions. Even as, okay. So, the top one's pretty easy. When x is 0, 3 to the 0 is 1. When x is 1, 3 to the 1 is 3. Those are the 2 points that I needed to draw my exponential function. This is y equals 3 to the x. The other one is just a mirror image. It crosses at negative 1. Instead of crossing a positive 1, it crosses a negative 1. And when x is 1, the first graph went up 3. This graph is going to go down 3. Okay, so you can graph, if you're asked to graph the second one, you can graph the first one and then reflect it like I did. Or you could now remember that negative a to the x graphs, either they go like this or they go like that. Okay, those are y equal negative a to the x graphs. And then you play the same game. If you want to graph y equals not 3 to the x, but negative 3 to the x. Let the exponent be 0 and 1. 3 to the 0 is 1. What's a minus sign in front of it? X is 1. 3 to the 1 is 3. What's a minus sign in front? So, when x is 0, I go down 1. And when x is 1, I go down 3. And there's your graph. Exactly what we got over here. We got the dashed one. So it's up to you if you want to remember yet 2 more graphs. Just 2 more things to remember. You already should know that if you have some function and you put a minus in front of it, the graph is reflected across the x-axis. So putting the minus in front doesn't really do much at all. Suppose you wanted to graph y equals 1 plus 2 to the x plus 1. if it makes your life easier, this is the same as positive 2 to the x plus 1 plus 1. So the vertex is 1 makes this 0, negative 1, and what's being added or subtracted? What makes this 1 is negative 1, and what's being added is 1. That's why the y value is 1. Okay, so now we have, quote, the new origin. X is negative 1, y is positive 1. It's as if that's the x-axis, and this is the y-axis. 1, negative 1. Okay. Now we let the exponent be 0 and 1. The exponent is x plus 1. If x is negative 1, then this will be 0. If x is 0, then this will be 1. 0 plus 1 is 0. Let's try that again. 0 plus 1 is 1. I want to pick x values and make the exponent 0 and 1. Okay, negative 1. 1 plus 2 to the x plus 1, or 2 to the x plus 1 plus 1. Doesn't matter. When x is negative 1, this is 0. 2 to the 0 is 1. 1 plus 1 is 2. Okay. Now, if the exponent is 0, 1 plus 2 to the 0 plus 1, 0 plus 1 is 1. 2 to the 1 is 2. So we get 1 plus 2, or 3. So when x is negative 1, we go up 2. When x is 0, we go up 3. There's your graph. Excuse me. These are 2 points on the graph. You know you get close to the new y-axis, and the graph goes like that. There's your graph. Okay, graph an exponential function should be funny. It shouldn't be brutal. Okay, that finishes graphing exponential functions.